Hello there. Today we'll be doing course scheduling. In this problem, we will be given a two-dimensional integer list of courses representing an adjacency list where courses I is the list of prerequisite courses needed to take course I. Return whether it's possible to take all the courses. So in example 1, we need to take course 1 to take course 0 and take course 0 take course 2. And if we can take course 1, then we can take all of these courses basically. So we take course 1 and we can return true. So immediately you can think about like how we can do this in depth first search, similar to the previous problem that we've just done. I think that was called keys and rooms, right? So in this problem, we can store the items rather than instead of going from each key to the next room, we are going to just remove the courses from each particular course. So let's do this very quickly because we're going to go through a second solution where we're going to use the idea of having loops. If we have a cycle inside the particular 1, 2, 1, 0, and 2, if there's a cycle here, right here, between 2 and 1, let's say 2 points to, 1 points to 2, then there's no way that we can take any of these courses and we're in a cycle. That means that we cannot finish this. So then once we know that, we can return false and not take any courses. So those are two different concepts. One concept is that we're going to go through all the courses, remove all the requirements for every requirements we see for each particular course, and we're going to add them back into any course that has not been taken and has no requirements, and remove those one at a time. And the other method is if there is a cycle, if we find one where we visit an item where we have visited before, then we know those courses, we can't take that course, and the only way out is to mark it and return false. Like, there's just no way to take the course. Right. So, what if 2 points to 1 and 1 points to 3 points to 2? So you have taken 2, but there's a cycle here, right? So let me just draw it out. So let's say, this is another separate idea. So suppose like we have this 2 and this sort of like circle, right? And we have a 3 here, which points this way, right? And of course we have this cycle of going this way and going down that way. What happens is that, well, you need to take 1 and 3 to take course 2 so that you can take course 0 so you can take course 1. So no matter what happens in whatever cycle, you would have to, it would not be possible. Anyways, let's solve this problem now. Let's get to the first item. So we're gonna have taken courses, and so we're gonna have a bunch of courses that we can take. Then we're going to create a stack. This particular stack is for I and requirements in enumerate courses. if not requirements. So basically, this line of code, we're going to take all the courses that do not have any requirements. So while stack, so we have the stack, and requirements equals stack.pop. Taken requirement is equal to true. So we have taken the course. So for each course in courses, we're going to remove this requirement. So I think we spelled something wrong here. That's fine. That's fine. We keep going. So once we have removed all the requirements, we want to check if we can add any of these. We can take these courses now. So let's try to take these courses and requirement and enumerate courses. So this takes up the index, and we're going to find out if there are no requirements, and we have not taken the class yet. Then we're going to append it, and we're going to take the class. We're going to try to remove all these requirements from the future classes, and if this all works, we're going to return all of taken. So run. It looks like it's accepted, and we have a solution here. So the reason why it's super slow, this particular solution, is because we have to go through every single course for every single requirement to check and remove it. This is an O of n operation right here. This is an O of this is an O of n operation for like it's O n times m, and we're gonna go through this whole thing multiple times. So to speed things up, we're just gonna find the cycle, and we're just gonna say, hey, there's a cycle here. Let's just quit because it's impossible for us to take all the courses. Okay, so here we go. So pre-map, this is the prerequisite map, is equal to the I points to courses. For I and courses in enumerate courses. So visiting. So we need to know if we're currently visiting the set, and we're going to do a depth first search of the course. So if the course is in visiting, that means we're currently visiting the course. We're going to have to return false because we see, and if prerequisite map, of course, so if the course is like, empty, then we can return true. One thing to note, do we really need the prerequisite map? Can't we just use the courses? I mean, it's the same. Yeah, it's the same. Okay, we'll just use courses then. But I think prerequisite map gives us like a better sense of what's going on, so we'll keep that. So visiting. So now that we're visiting the particular, we have the course. We're taking the course right now. We are in the course loop. We're figuring out if we can take this course. So in this, for each prerequisite, if the DFS of the prerequisite is not, return false. So basically what this means is that if we're currently visiting, return false. If yeah, essentially. So then we're not visiting, and so we can remove this item, and we can set the prerequisite map of the course to be equal to empty, and we can return true for this particular DFS call. So we're gonna have to run this for every single course. The reason for this is because we want to be able to catch non-connected courses. Some courses are not connected to every other course. So if you don't run it for every single item, you might miss out on those. And we're going to return true if this all passes. We're going to run through this code once just to make sure we understand how this works. This is not the fastest way of doing it because we are creating a set and everything that creates space and time complexity. But let's figure this. Let's go through this code once. So we have an example 0, 1, and 2. We have our prerequisites. 0 is going to prerequisite is 1. 1 prerequisite is nothing, and 2 prerequisite is 0. And we have a visiting item, and yeah, let's just do it. So currently we're at C. C is equal to 0, right? And we're gonna check if we can take the course 0. So CFS is basically, can we take the course? Is it possible to take the course? So in 0, we put the 0 in. 0 is in visiting. Well, it's not in visiting. And is it empty? Well, it's not empty. So we can't just immediately, say true. So what we need to do is now we're going to add 0 to visiting. So we're visiting 0. If we see 0 again in this loop, that means we cannot take this course. But that's not the case yet. So we're going to check if the prerequisites for this course, can we take those? So we look at 1, that's prerequisite, and we're visiting 1. C is 1 now. The prerequisite is 1. So we're here. Right. So we check 1. Is it in visiting? No, it's not in visiting. Is it empty? Well, yes. We just return true. Straight up returns true. So return true, and there's nothing else left. We can remove 0 from the visiting and set the premap to none for 0. Okay, done. Return true. All right, that's done. Okay, 1. We put 1 in. C is equal to 1. Check that. 1 flat out true. Good. Next, 2. We check 2. 2 is going to be here. We find out that nothing is visiting in 2. It's not empty, so we're going to put visiting as 2. Then we're going to check if the visiting is the prerequisite, can we take the prerequisite? Is it possible? So the prerequisite for 2 is 0, and we check 0. Look, the prerequisite's nothing, so it's true, so we're good to go. And we remove this, set this to, and return true. And we're done. We're done with everything, and we return true for this whole item. However, if, let's say, like we had 1 point to 1 and 1 point to 2, instead, we would find out what we have a loop. So let's try it again. So we throw in the 0, and it's in visiting. Okay, we need to go get the 1. We get the 1, and we find out we need to get the 2. So 1's in visiting, and now 2 is in visiting, right? Because we're looking for 2. 2 now points to 0. We add 0 back, and we return false. So so 0 goes in. 0 is false. So return false. This returns false. So that means this particular item returns false, and this particular item returns false, and this whole loop returns false, and we have false. So that's how it works. Let's simplify this code some more and speed this code up. It's going to look super abstract now because we're removing all the words. So what we're going to do is that we're going to set 3 different states. I want to have 1 to say we have seen it, not part of a circle. 0, not yet visited, and -1. -1. We have seen it in the course, but in a cycle. So we're gonna use this method to find out whether our graph is a cycle. If it's a cycle, then we gotta say, oh, it's a cycle. We can't take all the courses. So return false. Okay, so first of all, let's set the states is equal to 0. So what does this represent? This represents the visiting of the courses, and that way we reduce on the set that's necessary. So if state, so this is pretty much the same as earlier, where you equal to 1, which is, oh, we've seen it. It's not part of the cycle. Return false. If state of C is equal to -1, return true. So it's part of the cycle. We've seen it. It's part inside the cycle. That means we have not yet to reset it. That means we're still in visiting mode. So okay, so state of C, we're going to set it to visiting mode, which is -1. Oh, we're visiting right now. And for requirements in courses of C, if has cycle requirements, then return true. Otherwise, there is no cycle. That means we have not found a cycle here, and we're going to set it to 1 and then return false. With that, we can now do the same thing as we have done earlier, and for each course in range of length courses, we're just gonna if has cycle course return false. Otherwise, return true. Run. Submit. Okay, a little faster here, I think. Well, let's run through the code one time. I know this video is getting pretty long, but this is a tough problem, and we need to get as much reinforcement as possible, right? So 0, 1, and 2. We're going to give everything a 0. We have not visited anything yet. Okay, so what happens is that, of course, 0, these have requirements, right? So this has a requirement of 1, this has a requirement of nothing, and this is a requirement of 0. Okay, so what happens? What happens is that we have the state here. We're going to throw in the 0. We throw in the 0. Okay, have we seen it? Is it part of the cycle? Well, no, we have not seen it. We have not visited yet, so it's currently at 0. So we set it to -1. And we check its prerequisites, and that is a 1. So we check if 1 has requisites. If a 1 is in the cycle, then that means we're done. But it's not. So we check it. There's nothing to see there. There are no requirements, but we set it to -1. We check if it has a cycle yet. We check, and it seems to me that there's no cycle. So we can set it back to 1 now and return false. So there's nothing to see here, and this can be set back to 1. So we have 2 1s now, and we check 1. 1 returns false. It does not have cycle. We're good. We keep going. And we check 2. 2. It's a 0, so we don't know what's going on here. So we set it to -1 first, and we check the 0. Can we take it? Well, 0 set to 1, so set to false. So great, set to 1. Return false. and we can set it back to 1, and we're good to go. And that's it. And return. This does not return false, so it does not have a cycle, and we have all 1s here, so we can return true. And that's all for this particular checking if there's a cycle in anything. So the important thing is what we're doing here again is making sure if it's not part of a cycle, then we can return false. If it's part of a cycle, return true. So we set everything, we can throw everything into the cycle. Then we're going to check if it has any items that are in the cycle. And if there's nothing in the cycle, then we can return it back to it's not part of the cycle. So that way we can say, oh, we can take this course. Yeah, and that's all for this problem. Let me know if you have any questions or comments, anything you don't understand, anything that was not explained clearly. And if you enjoyed the video, please like and subscribe. And if you want more content, please check out the link in the description below. And that's all. Thank you very much, and have a good one.